Okay, let's review the use of the t-table, and I'm going to illustrate with some parts of problems that were in assignment 6. So let's begin with this problem. With n of 100, the degrees of freedom would be 99, and I want to calculate the probability of the left tail of 2.88. So to do this, I'm only seeing in the table here the upper tail probability. So how do I convert this? Well, whatever's in the left tail will also be in the right tail. So this is equivalent to looking for this probability, okay? So I need to go down to the 99th row. But the 99th row isn't there. The rule is when a row isn't there, we go to the closest row. Now, if the one that you're looking for falls neatly between two, like let's say if the degrees of freedom was 90, then we would choose to go to 80 instead, okay? That rule is so that particular, if we needed to create a confidence interval, for instance, the value of the critical value would be a little larger and the confidence interval would be a little larger. It's a little more conservative. Alright, so using 100 then, looking for 2.88, it is going to fall way up here, okay? It's going to fall between 2.871, sorry, and 3.174, so it falls in between these two. These correspond to these probabilities. So between the smaller value of 0.1 to 2.5%. So, going back up, the answer is between 0.1% and 0.25%. Okay? Alright, what if the problem was to calculate a p-value? I want a p-value for this test. It's a difference test. Okay, so it's looking for a change. The t-statistic, let's say, was 1.14. So what we need to calculate to get the p-value is, for a two-sided test, a p-value is going to be 2 times the upper tail probability. The degrees of freedom in this problem is 11 because n is 12. So I want to find 2 times the probability T11 is greater than 1.14. So I got to go to the 11th row and look for 1.14, and it's between these two, between 10% and 15%. So that would be 2 times between 10%. Alright, so between 10% and 15%. But I still have to multiply that by 2. So the p-value is actually, p-value would be between 20% and 30%. So if you were to test this against a 5% level of significance, we would have to reject the null. Fail to reject the null. because the p-value is not smaller than 5%. I'll write that as a percentage. You can write them as percent or as decimals. Since I started as percent, I'm going to continue as percent. So we would fail to reject because p was not smaller than 5%.